In this video, we're going to go over projectile motion questions. And the first question we have been given here. A stone is shot from a catapult at an angle of 60 degrees with respect to the horizontal. It leaves the catapult at a height of 1.7 meters above the ground level. So we take that the person who threw the stone is of that height. Alright, so we throw from the catapult like that, so it is going to go and drop down. So it is coming from an height of 1.7 meters above the ground, and then we've been told it is at an angle of 60 degrees, and then it leaves the catapult at a height 1.7 with the ground. Its initial velocity or initial speed is being given as 10 meters per second. Now that you have got all this information, and the first question is saying what is the maximum height of the stone with respect to the ground. So with respect to the ground, it's the very bottom there. What is the maximum height that the stone is going to reach? So before we get to find that, we need to first find this height here, the maximum height that the stone is going to go. So what equation are we going to use? So we can use 2gh is equal to v squared minus u squared. So this will be 2. The g, of course, when we are going up, that will be negative 9.8. And then the height, that is what we want. So in this case, it is x. So I'm going to put x there. And that will be equal to v. The final velocity when something reaches at this turning point is always 0. Then minus the initial velocity. Now remember, this stone is going, we are considering motion in the y. So we need to find the initial velocity in the y. So initial velocity in the y direction is given by velocity sin theta. So that's what we're going to put here. The velocity is 10, and then sin the angle of the floor is 60, so that will be squared. So to be able to remain with x is going to be 0 minus that will just be negative 10 sin 60 squared, and then we'll divide both sides by this term since we want to remain with x, to negative 9.8. So x is going to give us 3.83 meters. That is the height x. Now we want the height with respect from the ground. So we need to add also the height of this person who threw the stone. So h is going to be 1.7 plus 3.83, and that is going to give us 5.53. So that is it for this first part. Alright, the second part is saying how long does it take to hit the ground? So what do we mean by how long? When we hear a question saying how long, then we are looking for the time. So I can remove this part so that we work out the second. We're looking for the time that the stone is going to take to hit the ground. Remember, it's coming from here and then it goes down. So we can use two methods. Let me just show the two methods, and then you can choose which one is better for you. So the first one is to find the time it will take the stone to move from this point A to the maximum point B. That we are going to call it T1. And then you find the time it will take the stone to move them from the point B to the point C. That we are going to call it T2. So starting with the time T1, we are going to say V is equal to U plus GT. Now the final velocity at the maximum point here, B, is 0 because that's where the stone is turning. Then the initial velocity, remember we are talking about going up and down. So we are interested in the initial velocity in the x, because when you break down this velocity, it's going to have an x component and the y component. We want the y component because we are talking about motion going up. And the y component is always given by velocity sin the angle 60. Because we are going up, g is going to be negative 9.8 and then t. So take this 9.8 the other side, and remember this t is not just is t1, and that will be equal to 10 sin 60. So from here to find t1, we just say 10 sin 60 divided by 9.8, and t1 is going to give us 1.8878. Sorry, not that, but 0. 0.8255 seconds. Again, we need to find out the time from the maximum point here to the minimum point here. So the equations we are using depends with the data that we have. So we don't know the final velocity with which the stone is going to hit the ground. So we can't use an equation that has got final velocity. So the equation that I'm going to use for this second part is h is equal to ut plus half gt squared. The reason of using this equation is because I know the initial velocity at this maximum point. So at this maximum point, then the initial velocity is going to be 0. So the height now we are talking about here is the height, the total height from the very highest point to the very bottom there. And we already found that in the previous question. That gave us 5.53. And this is going to be equal to the initial speed is 0, as we are saying, from the maximum point there. So that will be 0 and then plus. Now here in this motion from B to C, the stone is dropping, so G is positive 9.8. And then we have got T squared. This will give us 5.53 being equal to half multiplied by 9.8. That will give us 4.9, and then T squared. And remember, this T squared is T2 squared. So from here we're going to divide both sides by 4.9, so it will be 5.53 divided by 4.9 is equal to T squared, and then we're going to square root both sides. Therefore T2 is going to give us 1.062. Now to be able to find the total time that the stone is going to move from the point A to the point C, we just add these two. So total time is T1 plus T2, and that is going to give us T1 is 0.8255, and then T2 is 1.062. When we add these two, we are going to get 1.8878 seconds. So that is the time that is going to take the stone to move from where it was thrown to the very bottom. If we don't want to use this formula where we find 2 times and then add, we can just go direct by using this equation. Height is equal to ut plus half gt squared. Now the height we are going to use is just the height of the building. Well, it's going to be negative height, and the question is, why is it going to be negative? So if the bottom here, that is where we are taking the position 0, and then the height of the building, we are going to measure it from the bottom, then it is going to be 1.7, and the stone has reached the bottom. That means it is on the position what? The position 0. So how do you find height? Height is given as a difference, so it will be final minus initial. H is the final position of the stone. The stone is going to be down, which is 0, minus the initial position, which is 1.7 meters away from the ground. That is why the height is going to be negative we are using. So this is negative 1.7, and that will be equal to, now this u is the initial speed in the y direction. Why? Because we're talking about the stone going up and coming down. So that is 10 sin 60, and then you have got at. Because the stone first went up, g is going to be negative, then t squared. So this is going to give us negative 1.7 being equal to 10 sin 60. That is going to be about 8.09, rounded off, of course. The numbers are a lot. T, and then minus half multiplied by 9.8, that will be a 4.9 t squared. I'm going to take this term the other side of the equation so that it crosses the equal sign, it becomes positive 4.9 t squared. Also this term, it crosses the equal sign, becomes negative 8.09 t, and then here we also have negative 1.7, and that is going to be equal to 0. So we have got a quadratic equation here. So we're going to use the quadratic formula to be able to work out t. So t is going to be equal to, from the equation, negative b, and our b is the term that has got a t. That will be negative 8.09 plus or minus the square root of b squared. B is negative 8.09 squared minus 4ac. A is 4.9, the term with a t squared, and then c is the constant, which is negative 1.7, and then everything divided by 2a. So when we work out this, we are going to find that the time is going to give us 1.84 seconds, or is more the same. And the reason as to why they are just different by a 4 and a 8 in the two equations, because of rounding of, like 10 sin 60 is not exactly 8.09, so such. Now we're going to find two answers on this question, but one answer is going to be negative. That's why I've just rejected the negative one. If you can see, I've got positive or negative. So this will just be positive 8.09 plus or minus this answer. So if you say minus, we're going to get a negative answer, and for time we're not interested in negative values. That's why I've just left that out. So let's take note of the time. That is the total time of flight there, the time it takes the stone to move from the top to the bottom. Now the third part, what is the horizontal distance traveled by the stone at a point it hits the ground from the bottom of the launch? So this is the top of the launch, like that. So we're looking for the horizontal distance. It is going to take the stone from the bottom of the launch to hit the ground. So that's the range there. And range is given by velocity in the x multiplied by t, because it is horizontal distance. So velocity in the x is given by velocity cos theta. So in this case the velocity is 10 cos the angle 60. Then multiply by the time of flight, and we calculated the time of flight as 1.84. So this is going to give us 10.815 meters. So this is going to be the range then for this question. Let's look at this one. A stone is thrown vertically upwards with a speed of 18 meters per second. So here we've got another stone. It is thrown vertically upwards, not at an angle. Okay, it goes up with a velocity of 18 meters per second. That's the initial velocity. How far is it moving when it reaches a height of 11 meters? Well, if they say 11 meters, first, what is the maximum height that this stone is going to go? You need to know that when it reaches the maximum point, the final velocity is going to be 0. Why? Because when it reaches the maximum point, it will turn and start coming back. Alright, so let's find first the total height of this movement. So we can say 2gh is equal to v squared minus u squared. So g is going to be negative 9.8. The reason as to why it's negative is because this motion is against gravity. We are going up. And then h, and that will be equal to the final velocity. We can see on the top, the final velocity is going to be 0. Then minus initial velocity is 18 squared. So 2 times negative 9.8, that will be negative 19.6 h. That will be equal to 18 squared. So we have got a negative 324. To find h, to be 324 divided by 19.6. And that is going to give us 16.53. So you can see the whole building has got a height, not a building, sorry, the whole motion. The stone is going to go the maximum height of 16.5, but we just want the speed that is going to take to reach a height of 11 point, just 11 meters. So 11 meters will just be maybe somewhere here. Okay, so how fast that is speed? How fast is it moving? So how do we get to find that speed? Well, we can say 2gh is equal to v squared minus u squared. So in this case, we've got 2g is negative 9.8 because it's going up, and then the height we want it to reach just 11 meters is going to be equal to final velocity. Well, what will be the final velocity? That's what we are looking for. The initial velocity of the throw, that is 18 squared. So if we arrange this equation, I'm going to get this term and take it the other side. So that will be positive 18 squared plus 2 multiplied by negative 9.8 multiplied by 11. is equal to v squared. So I want just to remain with v, so I'm going to square root both sides. Remember, when you square root, it will be positive or negative. So therefore, if we work out this, we're going to find that the velocity is 10.4, and it will be positive or negative 10.41 meters per second. And the question is, why is the velocity positive or negative? So if we take, this stone is moving going up. When it reaches this, it is going to reach this point twice. So the first one is when it is going up. So when it is going up, the velocity is positive. We are taking motion, we are taking, in this case, velocity going up as positive. So it's going to be here at a velocity of 10.41 meters per second. But it will continue going up, and then it is going to turn direction. When it starts coming down, the velocity changes. So at that very point, it is also going to have the same velocity, but the velocity is going to be negative. Why? Because it is going in the opposite direction. So why the answer is positive or negative there. And then the second question, how long does it take to reach this height? So how long? What are we looking for? Well, what we are looking for is time. And again, even for this one, we can use two methods. Remember, just to reach 11 meters, we can reach the 11 meters just when going up, we'll reach 11. Or we can first reach the maximum point and then start coming back like this. So we are going to find two time values. One time value will represent the time it will take for the stone to go up to reach at that point. Another time value will represent the time it will take the stone to move from the bottom going up and then coming down again to that very point, which is 11 meters. So let's work it out. Height is given by ut plus half gt squared. We want the time it will take to reach to a height of 11 meters, and that is going to be equal to the initial speed. We know it's 18. We don't know the time. That's what we are looking for. But because we're going up, g is going to be negative. That's why I've put a negative there. 9.8 t squared, and this is going to give us 11 being equal to 18t minus half multiplied by 9.8. That's 4.9 t squared. I'll take this 4.9 the other side, becomes positive 4.9 t squared. I'll take also the 18t, the other side becomes negative 18t. And then we have also a positive 11 that side, and that will be equal to 0. We also have a quadratic here. Using the quadratic formula, t is equal to negative b is negative 18, plus or minus the square root of b squared. B is still negative 18 squared, minus 4. A is 4.9, and then c is 11 divided by 2a. A is 4.9. So if we work out this one, we're also going to find two answers. The first one is going to be 2.899 when we use a positive, and then the other one, when you use a negative here, t is going to give us 0.774 seconds. So these are the two times, 2.899 or 0.74. If we don't want to use this formula to find the time, well, we can use another formula. We can say, let's first find the time it will take the stone to move from down, go up, and then come down again. The first thing that I'm going to find is just the time it will take the stone to go to reach the maximum point there. And we'll just say v is equal to u plus gt. Now, when it reaches this maximum point, the final velocity is going to be 0. The initial velocity, we know that is 18. And then g is going to be negative because the stone is going up. We'll take this time the other side, that is going to be 9.8t, that will be equal to 18. Divide both sides by 9.8, so that will be 18 divided by 9.8. So this time we can see is the time it will take for the stone to go and reach the maximum point. The time it will take the stone to reach the maximum point is the time it will take the stone also to go from the maximum point to the bottom. So if we want to find the total time to go up and then down, just multiply this answer by 2. And that will give us the total time of flight, which is going to be 3.673. This is the total time. Now we want the time just to reach 11 meters. What are we going to do? We can say v is equal to u plus gt. Find the velocity to reach 11 meters. In the previous question, we calculated how, just on the first part, how fast to reach 11 meters. We already calculated that as what? As 10.41. And that is going to be equal to initial velocity, that is 18. Because the stone is going up, it will be negative 9.8 t. So I'm going to get this term and take it this side, and then I'm going to get this term and take it the other side, more like arranging like terms. 9.8 t is equal to 18 minus 10.41, and then we divide both sides by 9.8. So t is going to give us 0.77. This is the first time. So the 0.77 is representing the time it will take the stone just to go and reach this point. What of this other portion which has remained? The time it will take the stone to go up, reach the maximum, and then come back to 11 here. How are we going to find it? Well, if we add this time it will take for this motion, and then the time it will take for this motion, it is going to give us the total time of flight, and the total time of flight is what we've calculated here. And therefore, the other time is going to be 3.673 minus 0.77, and that is going to give us 2.90. If we check and compare with the answers that we found with the other formula, these are all the same. The other formula gave us 2.88 and 0.77, which is basically the same, because 2.88, if we round off to one decimal place, it is going to give us 2.9, which is the same as this one, and then the 0.7 is the same as that one. So there are many ways to kill a rat. Let's consider this one here. A helicopter is climbing vertically at 8 meters per second. So let's say this is an helicopter which is climbing vertically upwards at what speed? At 8 meters per second. When it drops a pump near a leaking boat. The pump reaches the water, so remember, this helicopter is going up, but as it's going up it releases something, and that thing it has released reaches the very bottom after 4 seconds. Now, how high was the helicopter from the water when the pump was dropped? That's what we want. How high was the helicopter from the water when the pump was dropped? What can we do? What information do we have? We are looking for height. We have got velocity, which is the initial velocity in this case. Now, the initial velocity of the helicopter is 8 meters per second. This same initial velocity is also the velocity with which the pump is going to fall. But because the helicopter is going up, the pump is going down, so the velocity for the pump is going to be negative. That's the only difference. And then time is 4 seconds. That's the time it will take for the pump to reach down. Now, from the equations that we know, what equation relates height, velocity, and time? Initial velocity in this case. Well, h is equal to ut plus half gt squared. Remember, what are we looking for? How high? That's the height. So height is going to be, initial velocity is negative 8, and then time to reach the bottom is 4. And then remember, this pump is going down. This is going in the direction of gravity, so gravity is going to be positive. And then g is 9.8. And then the time here is also 4 squared. Work out this on your calculator. We should be able to get 46.4 meters. So that is going to be it for this one. Let's consider the one which follows. A ball is thrown with a speed of 40 meters per second at a certain angle theta with the horizontal. So like that. With this, now they've told us the velocity. We've thrown this ball with a velocity of 40 meters per second. Okay, what is the maximum horizontal range? What is the maximum horizontal distance it can go, given that the maximum height reached is 30? So this ball has reached a maximum height of 30 meters. We want to find the maximum range this can go, maximum horizontal distance. Okay, so that is what we are looking for. So let's work it out. The first thing that we should be able to find is the angle. How do we get the angle here? Well, there are many ways to be able to do it. And one thing that we can do is, let's first find, since we know about the, uh, the height, we can find the component of the velocity of the stone to reach this height. And how do we find that? We know that 2gh is given by v squared minus u squared. And this will be 2g is negative 9.8. The height it has reached is what? Is 30. And that will be equal to final velocity at this maximum point. Of course, it is in the y, is 0. The initial velocity we are talking about here, of course, it is initial velocity in the what? In the y also, squared. So vy squared here is initial velocity in the y. Now I want to remain with only vy. So this is going to give us negative 2 multiplied by 9.8 multiplied by 30 is equal to negative vy squared. So the negatives here are going to cancel out. Then we're going to square root both sides to remain with only vy. So vy therefore is going to give us 24.2487. Of course, it's going to be positive or negative. Now just write that. Now, how do we find velocity in the y? Velocity in the y is given by velocity sin theta. So in this case, velocity in the y we've calculated 24.2487, and that will be equal to velocity, the velocity of the throw, that is 40, and then sin theta. So to remain with theta, we divide first both sides by 40. That will be 24.2487 divided by 40. And then we'll take the sine inverse, since we want to remain with only theta. Sine inverse of 24.24 divided by 40. And therefore theta is going to give us 37.3 degrees. So we've calculated the second part, find also the angle. Now we can now work out the first question. What is the maximum horizontal distance it can go? And how can we find the maximum horizontal distance? Well, one thing that we need to know is first the time of flight. The time it will take the stone to go up and then reach the maximum point and then come back. How do we find that? We can say v is equal to u plus gt. The final velocity at this maximum point is 0 in the y. Initial velocity, this is initial velocity in the y, and we've already calculated the initial velocity in the y. Where? Okay, the initial velocity in the y is this one that we calculated, vy. So that's what we are going to put there, 24.2487. Because we are going up, g is going to be negative 9.8t. So this is, we'll take now this term the other side, it becomes positive 9.8t, and that is going to be equal to 24.2487. Divide both sides by 9.8, and that is going to give us 24.2487 over 9.8. So this is just the time taken for the stone to move from the bottom to the maximum point. The time taken also to move from the maximum point to this bottom is the same. So just multiply this value by 2 to find the total time of flight. So t is therefore going to be 4.9487 seconds. Now to find the maximum horizontal range. Range is given by velocity in the x multiplied by time. Velocity in the x is given by velocity cos theta. In this case, the velocity with which the stone was thrown is 40. So that will be 40 cos theta, the angle we've already calculated as 37.3. Then that answer we are going to find will multiply with the total time of flight, which is 4.9487. And this is going to give us maximum horizontal range of 157.4 meters. So that is it also for this one. Let's consider this one also. A bullet is fired from the top of a 200 meters high tower at an angle of 30 degrees below the horizontal with a speed of 50 meters per second. Find the time the bullet takes to hit the ground. What are we going to do for this one? The time it will take for the bullet to hit the ground. Well, from the data that we have, we know the height of the building, that is 200 meters. Another thing that we know, the initial velocity, that is 50 meters per second at an angle of 30 degrees below the horizontal. What else do we know? This is the data that we have. Of course, we also know g. And we want to find the time. Can say height is equal to ut plus half gt squared. In this case, the height is 200, and that will be equal to the initial speed. Initial speed. Now, because we're talking about height, then the initial speed you need to use is also the initial speed in the y direction. That is 50 sin 30. And then this we're going to multiply by the time t. The stone is coming down, so g is positive. That will be positive half. And then we have got 9.8 t squared. This is going to give us 200 being equal to 50 sin 30. Sin 30 is 1 over 2. 1 over 2 multiplied by 50 is 25. To be 25t plus. Half times 9.8, that is 4.9 t squared. I'll now take this term this side, so that we are going to remain with a 0 this side. And then if this term goes the other side, it's going to become negative. Negative 200. And then plus 25t, then plus 4.9 t squared. I can rearrange this, start writing. First I write the 4.9 t squared. Remember, the 4.9 is positive. Then I write the 25t. It is also positive, but the 200 is negative, and that will be equal to 0. Now from here we also use the quadratic formula, so t is going to be equal to negative b. B is positive 25, plus or minus the square root of b squared. B is 25 squared minus 4a is 4.9, and then c is negative 200 divided by 2a. If we work out this, we're going to find that t is negative 9.43, or t is going to give us 4.33. Well, when you're finding time, time should always be positive. Therefore, time is 4.33. That is going to be the time then it will take the stone to reach the bottom. A second part, what is the direct distance between the top of the tower and the point of impact on the ground? What do we mean by that? Direct distance. The first thing we need to know is that when this stone hits the ground, it will more move like that and reach that point. So here we have got the range, which is the distance from the bottom to where the tower, the top of the building. Now the direct distance is simply the displacement from the top to the very bottom where it is going to reach. This is the direct distance that we want to find. And let me just call it x, direct distance. Now to be able to find the direct distance between the top of the tower and the point where it hits, the projectile hits the ground, we first need to find the horizontal range. Because if we can see, this is the hypotenuse of this triangle. So to find the hypotenuse, you need to have the two adjacent sides. And how do we find the range? Range is given by velocity in the x multiplied by the total time of flight. Velocity in the x is given by velocity cos theta. And the velocity in this case, you can see the stone was dropping at 50 meters per second, and then cos, the angle is 30. The time of flight is what we've just calculated in the previous question as 4.33, and that is going to give us 187.49. Therefore, to find the direct distance x is going to be the square root of the height squared plus the range squared, because x is the hypotenuse. So x is going to be, therefore, square root of the height is 200 squared. The range is 187.49 also squared. Therefore, x is going to give us 274.14 meters. The other one, find the speed of the bullet when it hits the ground. What will be the speed of the bullet when it hits the ground? Well, to be able to find the speed, we need to know that when the bullet hits the ground, it's going to have a speed in the x and also in the y. So this velocity is going to be broken into vy and also vx. Now, when you're talking about projectile motion, vx is always the same. Velocity in the x is always the same throughout the motion. It's only velocity in the y which differs. So the only thing that we want to find is velocity in the y. We'll say velocity is equal to u plus gt. And this is velocity in the y, of course. So velocity in the y therefore is going to be the u. What u are we talking about? Now if we consider we are on the top of the building there and we are going in the down direction. So in this case, the initial velocity is going to be negative 50 sin 30. Now the question is, why is the velocity negative? When we are going in the down direction, we are taking the velocity as what? Negative. That is because we are going down. All right. And then g is going to be positive. For this question, let me just take motion in this direction. Let me take it like this. Anything going up is going to be positive, and then anything going up down is going to be negative. The reason for this, if you take the x or y plane, this is the positive y direction, this is the negative y direction. So let's use this axis to be able to work out this part. So that's why we're saying v is equal to u plus gt. So in this case, the final velocity in the y is going to be equal to the initial velocity in the y. Because velocity, the object is going down, we're going to take the velocity as what? Negative. But how do you find the y component? Y component is given by v sin theta. So that will be 50 sin 30. And then minus g is also going to be negative y, because we are taking motion going down as a negative. So that will be negative 9.8 multiplied by t, which is the time of flight, which we've calculated already as 4.33. Therefore, vy is going to give us negative 67.434 meters per second. This is not something to worry about. If we want, we can just say v is equal to u plus gt. Forget about taking the down direction as negative. Let's take the down direction as positive, or just the way we've been taking all these questions. So I'm going to say vy is going to be the velocity itself, the initial velocity in this case in the y. We'll just say it is 50 sin 30. G going down is positive, so that will be positive 9.8. The time is 4.33. Then this one is going to give us the answer as positive 67.434 meters per second. So the sign is just representing that we are going down. We are taking motion going down as negative. All right. Now this is the velocity in the y. We want the velocity with which it is going to hit the ground. We need also to find the x component of the velocity. X component is given by velocity cos theta. In this case, the velocity of the bullet is 50. Cos theta is 30. What is this going to give us? So that will give us 43.3 meters per second. Therefore, to be able to find the velocity, velocity is the x component squared plus y component squared, and then we square root. And that is going to be the square root of the x component is 43.3 squared. Y component is 67.434 squared. And that is going to give us 80.06 meters per second. So this is going to be the velocity then when it hits the ground. A girl standing at the edge of the bridge leans over the edge and throws a ball upward with an initial velocity of 15 meters per second as shown below. How high will the ball rise before it returns? So here is the girl at this point who throws a ball, and the ball is going to go and reach the maximum point, and then it starts falling to reach the waters down. So how high will the ball rise before it returns? So we want to find this height here. Well, what do we know? Do we know the initial velocity? Yes. The ball was thrown at 15 meters per second. And we know the final velocity at the top there is going to be 0. And we want the height. Easily can be done. So 2gh is equal to v squared minus u squared. This will be 2g is going to be negative 9.8. The reason is simple. We are going against gravity. Final velocity is 0. Initial velocity is 15, and we square that. So to find height, it's going to be negative 15 squared, and then we divide both sides by this term because we just want to remain with h. 2 negative 9.8. So punching this on our calculators, should be able to find h as 11.47959, which you can just write as height being equal to 11.5 meters. That's the maximum height it goes. Second part, how long does it take to reach the maximum height? So that is the time it will take to reach the maximum height. V is given by u plus gt. Final velocity on the top is 0. Initial velocity is 15 minus 9.8 t. The reason as to why the g is negative, we are going up. Then we take that term, the other side becomes positive 9.8 t, that will be equal to 15. Therefore, t is going to be 15 divided by 9.8, which is going to give us 1.53. So this is the time it will take to reach the maximum height. Now the third question, how long does it take to reach the maximum height? Okay, that's the previous one. The bridge is 8 meters above the water. At what time will the ball strike the water, and with what speed? So let's find at what time will the ball hit the water. So I can use this, the time taken for the ball to move from the top to the maximum point here as t1. That's the one we've calculated. And then let's find the time it will take for the ball to reach from the very top to the very bottom. That we are going to call it as t2. So therefore t2 in this case, how do we get to find it? So we are going to say height is equal to ut plus half gt squared. In this case, the height is going to be the total height, the height here and the height of the building. So the height we've already found, we've calculated 11.5 or 11.47959, and then the height of the building you've been told it's 8. So we're going to add the 8 plus the 11 point, that's 47959. So that is going to give us a total height of 19.47959. And that to be equal to initial velocity. Now in this case we are taking this as the initial position. Initial velocity there is 0, and times t to still be 0. G is going to be positive because we are moving down. So this will be 19.47959 being equal to half times 9.8, that is going to be 4.9 t squared. Divide both sides by 4.9. So this will give us a t squared, which will remain, and then square root both sides because we don't want to have t squared, we just want to have t. Therefore t in this case that is t2 is going to give us 1.99 seconds. So to be able to find the time it will take the projector or the ball to move from the bottom here of the building to the very bottom here of the building, or the top of the building to the very bottom, we are going to add these two. So 1.53 plus 1.99, that is going to give us 3.52. As I said, we have got more than one way to find the time in this case. So no, we found 3.52. We can use an equation that will give us a direct time without finding t1 and t2. And what equation is that? H is equal to ut plus half gt squared. Now the height that we are going to use here, of course the height of the building is 8, but we will not use 8, we are going to use negative 8. Hope we can remember the reason I gave. And then the initial speed, this is just the speed that we threw the ball with at this point, and that was 15. Then multiplied by t. Of course, g is going to be negative because we are first going up. That will give us negative 8 is equal to 15t minus 4.9 t squared. I'm going to take these terms the other side of the equation. The 4.9 is going to become positive. The 15 is going to become negative. The 8 is also negative. That will be equal to 0. Using the quadratic equation, t is going to be negative b, which is negative 15, plus or minus the square root of negative 15 squared minus 4a is 4.9, and then c is negative 8 divided by 2a, and a is 4.9. So punch this on your calculator, should be able to get 3.524. Of course, we are going to find two answers. One is going to be negative. You just concentrate on the positive one. So this is the same answer that you found. So this is the time it will take to hit the ground. But the question is saying, at what time will the ball strike the water and with what speed? So we also want to find the speed with which the ball is going to hit the waters, and say v is equal to u plus gt. We want a final velocity at this point. Initial velocity here we know is 0. So v is going to be initial velocity 0. G is positive 9.8. Now t, the time taken for the ball to move from the maximum point there to the very bottom here, we calculated that as 1.99. Therefore, the velocity it is going to take the ball to reach the bottom. Now this is free fall, so there is no x component and y component. We only have y components. 9.8 multiplied by 1.99. It is going to give us 19.5 meters per second. So that is going to be it. Let's consider this one. A jet plane is flying in a horizontal direction. Here we have a jet which is flying in a horizontal direction at a velocity of 600 kilometers per hour at a height of 1960 meters. So the distance from the bottom here is 1960 meters. When it is vertically above a point A, this is a point A, on the ground, a package drops from it. So a package is released, and that package is going to drop. The package hits the ground at a point B. Calculate the distance AB. So we want to calculate this distance. What will be it? Well, what can we do? Now, the plane is moving horizontally. The same velocity of the plane is going to be the velocity of the package that is released. But because the plane is moving horizontally, that means even the package is going to just have an horizontal component of the velocity. There is no y component. Now, the first thing is, let's convert this velocity to SI units. 600 kilometers per hour. We have got a kilometer on top. We're going to put a kilometer down, and then a meter on top. In 1 kilometer, we've got 1,000 meters, and then also multiply. So here the kilometer will cancel the kilometer. We have got a hour down, we put a hour on top, and then we want a second. In 1 hour, we know we have got 3,600 seconds. The hour and the hour cancel, so the answer is now in meters per second. If we punch this, we're going to find 166.67 meters per second. Now we can say height is equal to ut plus half gt squared. The height above the ground, that is 1960. I want to find the time of flight, the time it will take for the passenger to move them from the top to the bottom. Now the initial speed here is going to be 0 for the package. Why? There is no speed in the y direction. Remember, the plane is moving in the x direction. Even the package is going to just receive a velocity, a component in the x direction, and then plus half. So the package is dropping. G is positive 9.8 t squared. This will be 1960 is equal to half multiplied by 9.8, that's 4.9 t squared. Divide both sides by 4.9. And then to remain with t, also square root both sides. Therefore, t is going to be 20 seconds. This is the time of flight. Now I want to find the horizontal distance AB. AB is simply the range, and range is given by velocity in the x multiplied by t. In this case, the velocity in the x is simply the velocity of the plane, which is 166.67, then multiplied by the time of flight, which is 20, and that is going to give us 3,333 meters. So that's the horizontal distance. A projectile is launched from the ground level to the top of a 155 meters high cliff, which is 195 meters away as shown in the figure. If the projectile lands on top of the cliff 7.6 seconds later after it was fired, find the magnitude and direction of the initial velocity of the projectile. Magnitude and direction of the initial velocity. We know the height, we also know the horizontal range. We want to find the magnitude of the initial velocity and also the direction. Direction is simply meaning angle. So firstly, a range is given by velocity in the x multiplied by the time. And the range, we know that is the horizontal distance is 195, and that will be equal to velocity in the x. The time of flight, you've been told it reaches or lands to where it is going 7.6 seconds later. So therefore velocity index will be 195 divided by 7.6, and that will be 25.65789 seconds. I mean meters per second. This is velocity. And then we can now talk about height. Height is given by initial velocity times time plus half gt squared. The height is 155. That will be equal to initial velocity. Now this u is the initial velocity in the y direction multiplied by the time, which is 7.6. Well, the projectile is going up, so g is negative. We have got 9.8, and then the time is 7.6. We're supposed to square this 7.6. So this will give us 155. I'm going to take this term the other side, so it will be positive now. 1 over 2 multiplied by 9.8, then multiplied by 7.6, which is squared, and that will be equal to Vy multiplied by 7.6. We don't want the 7.6, so divide both sides by a 7.6. So if you punch this portion on the calculator, you are going to find that Vy is going to be 57.6347 meters per second. Now we have the y component and the x component. Velocity is given by the square root of the x component squared and y component squared. So the x component 25.65789 squared plus y component, which is 57.6347 squared. That is going to give us a velocity of 36.285, which we can just say 36 to one number, or 36.3 meters per second to one decimal place. Now we also need to find the direction. Direction is given by theta is equal to tan inverse of y component over x component. The y component is 57.6347, and then x component is 25.65789. Therefore, the theta in this case is going to give us 66 degrees. That is it for this question. And the last one in this practice here. A projectile is shot from the edge of the building top, which is 125 meters above the ground level, with an initial speed of 65 meters per second at an angle of 37 degrees with the horizontal as shown. The time, so determine the time taken by the projector to hit the point P, that is to hit the bottom. Well, we can also use two formulas for this one, but let me not use both since we've already seen how to use both. I'm just going to use one formula. So I want to find the time it takes for the projector to move from the top to the very bottom, which is labeled P. And I'm going to use only one equation. Height is equal to ut plus half gt squared, and the height of the building was 125, but we're going to use negative 125. If you've forgotten where the negative is coming from, please watch the first question, which we use this one. I explained on that. And the initial velocity, we can see we have got 65 at an angle of 37, but this is in the y, so that is going to be 65 sin 37, and then this will be multiplied by t, and then we have got g is going to be negative because we are going up, so this will be negative half. G is 9.8 t squared. From here we are going to have, so I'm going to simplify this one. We have got negative 125. If we punch on the calculator 65 sin 37, that is going to be 37.117, and then we have got t minus half times 9.8, that will be 4.9 t squared. Let's take this one over the other side. It becomes positive 4.9 t squared. The 37 also becomes negative, sorry, this is not even 37 by 39.11, and then the 125 is still negative because it doesn't move. To find t, we use the quadratic formula. T is equal to negative b, which is negative 39.117, plus or minus square root of b, which is 39.117. Of course, it's negative. We square it. Minus 4. A is 4.9. And then c is negative 125. Everything divided by 2 multiplied by a, which is 4.9. So this will give us t being equal to 10.43, or t being equal to negative 2.45. I'm only interested in the positive t, therefore it is going to be 10.43 seconds. Try to use the other equation, you see what we're going to find, and that will be the same basically. So this is the time of light, or the time it will take the projectile to reach the bottom. The second question: determine the range x of the projectile measured from the base of the building as shown. So this range x measured from the base of the building. So range is given by velocity in the x multiplied by the time of light. Velocity in the x is simply velocity cos theta, and the velocity here is 65, cos the angle, which is 37, and then multiply by time of light, which we've calculated as 10.429 or 43, and that will give us 74.18 meters per second. And then for the third part, the magnitude of the velocity just before the particle reaches the ground. So just the velocity here, the magnitude of the velocity, how are we going to find that? Well, it has got the x component and the y component, so we need to find those two components. It's going to have the vy and also vx. So we need to calculate vx and also vy, and those two are the ones which give us now the velocity just before the particle hits the ground. So let's first find vy. So v is given by u plus gt. In this case, we're talking about vy. Initial velocity in the y. Okay. So if we take motion from the maximum point here, let me say, if I take motion from that maximum point, then the velocity, initial velocity is going to be what? Is going to be 0 in the y. But let me not use this one. Of course, we can use it, and it's going to come out. The answer is the same. Let me say 2gh is equal to v squared minus u squared. In this case, we're saying 2g is going to be negative 9.8. The reason as to why it is negative is because we are talking about g. The projectile is first going up before it can come down there. Okay, and then the height is the height is 125, but we are going to use negative 125. The reason of using a negative 125, simple, because we are going at the bottom here where the height is 0, and then here the height is 125. When you are finding height, it is final position minus initial position, so 0 minus 125 is negative 125. and that is going to be equal to final velocity in the y minus initial velocity in the y. Now the initial velocity in the y at this point is given by v sin theta. V is 65 sin 37 squared. So just take this term the other side, add to this term, and then square root. You are going to find v. In this case, it is velocity in the y. It will be 63.088. That is going to be it. Of course, you can use the previous formula that I wrote, but for that one, you just need to find first the time it will take the projectile to move from this maximum point to the bottom. That's what the one you are going to use. Now we've found the velocity in the y. The velocity index is given by velocity cos theta. Velocity is 65 cos 37, and that is going to give us 51.911 meters per second. Velocity in the x doesn't change. The same at the beginning will also be at the end, so it doesn't change. And then I can find the velocity. Velocity is going to just be a square root of y component plus x component. And that is going to give us 81.6997, which we can just say 82 to whole number, or 81.7 meters per second. And then the part 4, calculate or determine the angle omega or theta below the horizontal made by the velocity vector. We want to determine this angle here. Well, quite strict. How can we calculate that? Angle tan theta. In this case, this is not theta. I've forgotten the symbol's name anyway. So tan, let me say theta, is going to be x, y component over x component. Whenever you're finding directions, always y component over x component. Y component is 63.088 over x component, which is 51.911. So therefore, theta is going to be, we'll take the tan inverse of this portion. And that is going to give us 50.6 degrees. So that's the angle of the launch. Then the last one, I want to determine the maximum height reached by the projectile from the top of the building. Maximum height from the top of the building. So all we are looking for is, this is the top of the building, just how far it has gone up to that point. How do we calculate that? So we're going to say 2gh is equal to v squared minus u squared. So be 2g negative 9.8h. Final velocity on top is 0. Initial velocity, of course, it is in the y direction. 65 sin 37. And to find height, it will just be negative 65 sin 37, then divided by 2 multiplied by negative 9.8. Therefore, the height there is going to be 78.07 meters. So that is going to be the total time, I mean the height from the top to the maximum point of the projector. Well, thank you so much for having watched. Please, if this was helpful, remember to subscribe and also get just to share the video with others. Stay blessed.